Hello. I'm gonna wait a few more minutes before getting into it to wait for people to trickle in.
Hello.
Hello.
Thank you so much for being here today.
Oh yeah, of course. Thank you so much for having me. I'm excited to present. How's the event going so far?
It's going pretty well. We're on day 3. We have an awesome lineup today, including you, so I'm pretty excited for today.
That's awesome. Wow, I can't imagine planning. I planned a hackathon when I was in college too. I can't imagine doing 4 days. Ours was 36 hours, so that's super impressive.
Oh yeah, I guess we were thinking since it is virtual, maybe people would need like more time to work on their projects, so that's why we kind of made it a longer hackathon. But yeah.
That's awesome. Is this the first year of IvyHacks or
Yeah, this is the first year.
that's awesome. Yeah, because I've never heard of it before this year, but I know like each individual college has their own hackathon. So that's awesome that you all did a collaboration.
Yeah, wait, what was the hackathon that you organized before?
I don't know if you've heard of Tech Together
Oh,
Boston.
right. Yeah. No, yeah, I'm actually from the Boston area and I went to Hobby Hacks like earlier this year, which I think is like hosted by Tech Together.
Yeah,
Yeah,
yeah.
it was a lot of
That's
fun.
awesome. Wait one more minute. And I'll share the slides and get a shareable link. Have a chat button, which is
Oh,
weird.
yeah. Sorry about that. So we disabled chat for like the majority of the event. So we're just using
Oh,
Discord to kind of ask questions. So do you have access to the Discord or no?
yeah.
Okay. If you want to post it in like under the channel that says event discussion, that would be amazing.
Yeah, of course. I'm a grandma when it comes to Discord. I'm like, where is everything? Event discussion, found it. Well, I just posted the slides if you want to follow along in the event discussion channel. And I'll also share the code towards the end of the workshop, and I'll leave plenty of time for questions. Let me just share my screen. Cool. Can you see my screen?
Yeah.
Cool. Um, whoops. All right. Hi, everyone. Thank you so much for joining the introduction to WebSockets or real-time communication using WebSockets workshop. A little bit about me. I'm Sreeya. I'm currently a software engineer at Drift, and we are a B2B software platform that helps buyers and sellers connect to each other. So if you ever go to a website and at the bottom there's like a chat bot, that might be Drift, that might be our competitor Intercom. There's a lot of chatbots out there, but basically our main product is chatbots, and that's my email and LinkedIn if you want to connect with me after. If you have any questions for me after, feel free to shoot me an email or connect with me on LinkedIn. So this is a general overview of the workshop. First, I want to set some foundational knowledge before we get into WebSockets. And then towards the end, which is going to be my favorite part, we're going to dive into some code and make a little chat app called the IvyHacks chat app. So yeah, let's get into it.
1 second, I'm so sorry to interject, but Sreeya, could you, if you don't mind hitting record at the bottom, just so the workshop is recorded, that'd be amazing.
Oh yeah, sorry about that. I think
No
I
worries.
have to stop sharing and then share.
All right, so sorry. Oh, and could you
Oh
also make Allison Lee in the participants a co-host? She's the moderator for this talk, so that would be amazing.
yeah, of course. Allison Lee. Co-host. And I think it is recording. It says recording at the
Oh,
top.
yeah,
So
it is. Okay,
hopefully
sorry.
that records it. Awesome. I just made Allison a co-host. And then I think I have to share again. God damn it, Zoom. Cool. Can you see my screen?
Mhm.
Cool.
Great.
So before we get started, I want you to think of your favorite social media apps or your favorite game. Maybe it's Scribble or Among Us, all those popular quarantine games that you play on a daily basis, or even Slack if you use that for school or work. And majority of them rely on data to be in real time. So on Slack, for example, when I'm messaging someone, or even on Zoom, like when we had Zoom chat, like when you type to someone, everyone else, that chat gets broadcasted to everyone else, and everyone is able to see your information. And especially now, since everything is virtual, we want to emulate online that in-person connection virtually. So real-time data has allowed us to do that for however many years, but it's even more important now since we're all virtual. So to set some foundational knowledge before we dive right into WebSockets, so the basic architecture or structure of a web app involves a client. So that's this guy over here. That's what you see when you go to a website. So say I am a user and I go to Amazon and I see like a list. I'm searching for shoes and I see like a list of shoes. So that is the web client, and it is basically like what the user sees, what the user interacts with. And then there's the server side, which is what the client interacts with in order to update resources or store data on Amazon's server, Amazon's backend. So when I add items to the cart, that basically updates some resource on the back end, like storing the data that the user selected to Amazon. So this is a general flow of when or how a web app works and when a user goes to a website, like the basic flow of data. And it's very client initiated. So when I go to a website, I have to like trigger an action on the client in order for it to send a request to a server. So that is the request response method of traditional HTTP. And HTTP is Hypertext Transfer Protocol. It's the standard method of communication between different applications. So if we go back to our client server architecture again, the client is the one that's initiating requests to the server in order to say like, when I go to a data, when I go to a website, I want all the data. Say you're on like Airbnb, I want the data for all the listings. So the client is the one that's initiating it. The server can't really initiate. So when the server has data, it can't really initiate it to the client. So there is an HTTP request is a structured way to send data. And it's basically like having a structure for when different applications communicate with each other over a network. So the two most important methods or most common ones are GET and POST. So I'll show an example about this after. So when you go to a website, so like we were talking about earlier with Amazon, and you want to view all of the items in Amazon, say like for shoes, when you load that page, it sends a get request and it's like, get me all the shoes that I have in my catalog. And when you as the user want to like fill out a form, say you're like signing up for Amazon or you want to add items to your cart, you are submitting a form and then it sends a post request, which like creates a new resource in the back end and saves your data. So those are the two most popular methods. There's also delete, which is like deleting items on the back end or deleting items on the back end. Um, so there are some limitations with this request response model because, like I mentioned before, the client has to initiate everything. So with our chat app example, we have three people talking: Alice, Bob, and Sam. They all have they're all communicating with different web browsers or different clients. So Alice sends a message to, she wants to send a message to Bob and Sam. So she posts a message to the server. And Bob and Sam, like the server doesn't know that it needs to send a message to these two clients because everything is initiated from the client itself. So Bob and Sam have to sit and trigger an action, and that action might be a page refresh in order to get all the new messages from Alice that Alice sent to the server. But that's like really annoying as from a user perspective because you have to sit there and keep refreshing your page. And like that's not, you don't really even know when Alice has sent a message. So there's some limitations. Like this isn't actually real time. This is something and the client has to trigger an action to get a request of data from the server. So one potential solution to this is polling. So basically in this instant, when Alice sends a message or wants to send a message to Bob and Sam and it goes through the server, client 2 and client 3, Bob and Sam, we can basically put a timer there and say every 5 seconds I want to send a request to the server and get all the new messages. So in this case, Bob and Sam don't have to keep refreshing the page. And the clients will send a new request every 5 seconds in order to trigger like a new request or trigger a new request to get all of the chats. Yeah, but this is, as you may already know, not really real time as well, because sometimes there might not be new messages, like Alice might not have sent new messages, and you have to wait 5 seconds, which doesn't sound like a lot of time, but when we're doing like gaming or just like any type of communication, any type of messaging, 5 seconds is actually a very long time to have to wait for an update from other people. Like pretend you're playing a card game and you have to like sit there and wait for 5 seconds after your opponent has made a move. That doesn't really provide the best user experience. And not only is it an inconvenience from a user perspective, it also causes a lot of unnecessary requests, a lot of latency, because say like there's no information being transferred for like a minute, you're sending a bunch of unnecessary requests and transferring a bunch of unnecessary data that causes some overhead. So this is a potential solution, and a lot of people don't have like, if you say like an activity feed, for example, that doesn't like really have to be in real time, like it can update every 5 seconds. HTTP polling is definitely an option for you there. But if you want to do something that is instantaneous, like when someone sends a message, like I get that message, then we need to use WebSockets. So before I get into WebSockets, I want to show you an example of the HTTP, traditional HTTP request. Something fun, Spotify app. So I'm just gonna start this server locally. Cool. And every time I'm building a web app, I always utilize the network tab or the Google Developer Console. So here you can see all the requests. Let me just clear this. You can see all the requests that are happening. So here, when I load this page, I'm sending a GET request, and I'm getting this whole like HTML page with a bunch of information. So these are all the songs I listened to recently, and this is, nothing is playing now, but this will display my currently playing song. As you can tell, I listen to a lot of Taylor Swift. I need to have a broader taste of music. So if I start playing a song, let me play another Taylor Swift song. So if I play like Blank Space, here I'll start saying, I'm currently, oh, whoops, that token has expired. Restart this. Cool. So Blank Space is currently playing. But if I change the song to the next one, so this is Betty, this page doesn't refresh because, so the server, the song changed on the back end, but the client doesn't know that. So I have to sit and refresh the page, and then that triggers a new HTTP request here. So that reloads the page and gets like the new information. So it's not really in real time, but this kind of shows you how traditional HTTP works, how it's very one-sided. It's always initiated from the client. Cool. That's a web app I made for a workshop a few months ago. Cool. So back to WebSockets. So this is our solution to this problem. We want a bidirectional channel of communication between the client and server, so that when something gets updated on the server side, it can like push that information to all the clients, and the client doesn't need to know or like wait for anything. Like it's sent instantaneously or in real time. So a WebSocket provides a persistent channel of communication between our client and server. And the way that the connection is opened is between a handshake. So basically the client and server have to both agree with each other that we want to open up this channel of communication, and we want to be able to talk to each other at all times. So the way that this works with Alice, Bob, and Sam, so Alice's client initiates a handshake with our chat server. So does Bob, so does Sam. So these three users are connected to this one server. So as soon as Alice sends a new message from her client to the server, it gets broadcasted to Bob and Sam. So it's an instantaneous form of connection, or it's like bidirectional. So when the client sends something to the server, it sends it instantaneously to the clients. And the clients can keep sending data to the server, and it'll keep being broadcasted to everyone. So our communication channel is in real time. And with that music example, as soon as that song is changed from Spotify, the server will send a message to the client indicating that, oh, there's a new song playing, please update the UI. So that's how we can do things in real time. So in order to establish a handshake, this will be established over a single transmission control protocol connection. So this is just a simple connection between the client and the server. And this is an example of the request that the client sends to the server in order to establish a handshake, or to say, hey, I want to upgrade our connection to be bidirectional. I want to be able to send data from the client to the server, and like allowing or being able to listen to the server for new information. And then when we get into the implementation, I'll show you in the network tab how this handshake works. So one last thing is called ping pong. So in order to keep the bidirectional connection alive between the server and the client, a technique called ping pong is used in order to ensure that this connection is still there. Sometimes browsers like close your WebSocket connection if there's no, like say no one is chatting for a minute or like 30 seconds or there's no messages being sent, it closes the connection, which we don't want to happen. We want to keep the connection alive, and we also want to make sure that there's no disruptions in the network, and to still be able to send messages between these two systems. So we'll also talk about how to implement ping pong as well to keep our connection alive. So now to the fun part. We're gonna be making a little chat app called the IvyHacks chat. It's exclusive to only us, or no, I'm just kidding. So here, the two requirements are, we want to, when I send a message, we want it to be broadcasted to everyone, and similarly with every single client connected to this chat. And we also want to know when a new user joins, and that will be triggered when a handshake is initiated between a client and a server. And in order to represent this data, we're going to do two different message types. So the first one is when a user joins the chat, and the second is when a user chats in. So for technologies, the client side, we're going to be using React.js. It's a framework in order to manage the state of your client side. So every time we get a new message from the server, we're going to keep track of it in the state in order to display it out to everyone. And then on the server side, we're going to use Express to create our server and to manage the WebSocket connection. And also on the client side, there is a WebSocket API that is supported by most browsers, so we're just going to utilize that. And then on the server side, we're going to be using a WebSocket package that you can install with NPM, the Node Package Manager, in order to manage the connection from the server side as well. And so this is just like an implementation example using all JavaScript, but if you prefer Python, I have some examples at the end for how you can utilize Python. You can also do Java. I recommend sticking to like JavaScript or Python for hackathons, since Java takes some time to set up. I use Java at work, but it takes some time to set up, and hackathons, we don't want to spend so much time setting up things as I've done at past hackathons. Cool, so now it's time for some code. Let me go over here. So this web app is the primary code for this web app is in two files. It's in this index.js file. So if you look at the file structure here, I have my client file, which is the React app, and then I have the server. So this index file is just in this server file over here. And the client app was made using the Create React app. If you're familiar with React, that's how you can generate a template for a React app. So cool. I'm going to start, first of all, with how to do the handshake. So I imported here the WebSocket library from Node. And over here, this is how you initiate a new WebSocket connection on the back end. So this server, this is using Express. So here, we're building a new server. This build file here, I'll get into that later. When you want to deploy your file onto, or deploy your app onto Heroku, this is what you do in order to like build out, to have it serve the index.html, the build file produced by the React app, but I'll get more into that later. And our Express app is listening on this port here that I defined as 8080. You can make it whatever you want, it doesn't really matter. Cool, so over here, we're going to start by checking if there is a connection initiated from the client side. So I'm taking my WebSocket connection or server here, and I say on a connection, So when this client connects to the server, this is what's called a callback function. So when there's a connection, it's going to execute this function over here. For now, I'm just going to console log like connection on server side, so we can see what's going on there. And I'm going to go to my React app here. So the majority of the code for the React app is in this chatapp.js file. I'll go into more detail on what each of these components are doing, but right now in our state, we're just keeping track of all of the messages that we've gotten from the server, who the current user is, and the current message that the user is typing. And over here, this is the WebSocket API provided on the client side, so you don't even have to import anything in. This API is already implemented, and it helps manage and create a WebSocket connection to the server, which we defined in the index file. So in order to check that there is a connection or that a new WebSocket connection has been opened, in this component.didMount file, we're going to check that there's a connection open, and component didMount gets executed every time the app gets mounted or this component gets mounted. So the way that React works, for those who aren't familiar, is every time there's a change in the state, it calls this render method and re-renders your whole app over here. So when there's a change in state, we want to, or like when this new component gets mounted, it's going to keep executing this function over here. So it's great for doing a bunch of network requests. So previously, if you're doing traditional HTTP, like when your page loads, you want to get a bunch of data unload from your server, it's best to do that in here. So in order to check if the WebSocket connection has been opened, we're going to call this WebSocket that we've initialized here and say on open, we are going to, just for now, console.log, say client connected, just to see what is going on here. Cool. I'm going to save everything. So in order to run this app locally, I'm going to execute npm run dev. So all the scripts for running your apps are defined in package.json. So over here, when I run dev, it's just running my client file. And if you go to client, it's seeding into the client and saying npm start, which is another script in there. And it's running the server concurrently, which is which I like to do in dev mode, so you don't have to like start your client and start your server in two different terminal files. Sometimes it gets annoying and confusing. So I use this library to start those two things up together. So if I do npm run dev, and I go to localhost 300, we have an app here. Oops, let me read this. Cool. And if I go here, back in the presentation, so this over here, we've established our connection upgrade header, which shows that the client has asked for to establish a WebSocket connection with the server, and that we've upgraded our connection and that it was a success. So the switching protocols is a good thing. And once we start sending messages, we can see all the messages that get sent over here, which was really cool and really nice to use this developer console. So yeah, we established a handshake between the client and server, yay. So our first requirement for this app is when a new user starts or joins this app, we want them to have, or want to have them enter their name here. But when a new user joins, we want to broadcast that to everyone else in the chat room, just so we know like who is in the chat room. So in order to do that, we're going to send a new message or have this client send a message to the server and have that server broadcast that to everyone who is connected. So in order to do that, I'm going to go back to the server side over here. And over here, when there's a connection and that client sends a message, so on message, it's going to execute this callback function, which takes in a message. And basically what we want to do here is we want to broadcast this incoming message from this client that sent it to everyone, to all other clients that are connected to this WebSocket. So in order to access all the other clients, we can access them through here. This WebSocket server has this property called clients, where you can get all of the clients that are currently connected to this WebSocket server. And for each of these clients, we want to broadcast a message, but first we want to check like if the client does not equal the client that sent the message, because we don't want to broadcast the message back to ourselves. And the client that we're broadcasting the message to is open. I believe it's websocket.open. Then all we have to do is send the message to that client like that. And back to the client side of things. So in our React app, in our component did mount method over here, we want to check over here that when we get a new message, we want to add that to this messages. So this state here has a messages attribute, and it will keep track of all of the messages that we receive from the server. So if my client is on the receiving side of this message, I want to add that to the state. So here I'm just parsing the message since it's a string and we want to turn it into a JSON object, which will allow us to access the attributes of that data easily instead of having to like parse a string, which can be annoying. So this way over here is saying I want to get all the current messages in the state, and I want to add the incoming message to there. That's some like syntactical JavaScript sugar. I feel like JavaScript is a lot of weird like syntax things that I learn every day. And then we want to set our state. So we want to set messages to all messages. So yeah, here we're adding our incoming message to the list of messages we already have, and then we're updating the state to reflect that. So one last thing, when someone submits their name here, that logic is done down here. So enter name input. So we have this form, and when the form gets submitted, it executes this submit name function that is passed down from the parent component. So this chat app component here, I'm just having this component manage the state of everything, and having these like stateless components here to make our lives easier and just have like one component manage the state for everything. So when you submit a name, this function over here gets called. So when I submit the name, I want to send a message to the WebSocket in order to let everyone else, or have that message broadcasted to everyone else to let them know that a new user has joined the chat. So we're going to make a new message to send to our WebSocket, and I've identified the type to be new user joined, and these types are defined up here. These are the different message types I've created, just so we can distinguish between the two. And we want to give the username of the person who joined. So we're going to take this new user. So this is the user that was written into the text box, and that's how you access it. And we're setting the state to keep track of who the current user is. And we're creating this message that says new user joined. And then the last thing that we need to do is we're taking this message and submitting it to the WebSocket. Sweet. So first, just to reiterate what we just did, on the back end here, we're taking all the messages that the WebSocket on the server side has received and broadcasting it to all the clients. And then on the client side, whenever we receive a new message, we are putting it or storing that in our state here messages. And every time we submit a new name, we're sending that through the WebSocket to the server side so that all the other clients can get the information that a new user has joined. So if we go back to here, we can see client connected here, which is great. And I'm just going to open up an incognito window. So this is how I test stuff with WebSockets locally. I'm basically like talking to myself. And opening up an incognito window creates a new session. So here I'm going to say my name is Bob. If I submit that, I can see here that Bob has joined the chat. So if I go to the network tab and go to the WebSocket connection here, I can see that a new message was sent here, and we can see the data is new user joined. And similarly, if I go here, and I might have to, oh, whoops. Let's try that again. I might have to refresh everything. Cool, so now we can see the network tab. So again, if I enter Bob here, I can see it in here, and I can also see it in here. So this down arrow says, like, I received this new message, Bob has joined. If I say Alice here, it's broadcasted here that Alice has joined. Sweet, so now we know who has joined our chat. So the second thing that we want to do is whenever I type a message into this box, I want it to be broadcasted to Alice over here. And when Alice does it, it should be broadcasted to Bob. And just to quickly go over, I already have all the rendering in here, but just to quickly go over how the messages are rendered, it's in here. There's this message stateless component here that basically looks at all the messages that we have in our state and says, if the message type is new message, then, if the message type is new user joined, just get the name from that message and say that they've joined the chat. So that's how the rendering is done over here. Cool, so there's just one little thing we have to add in our code in order to be able to send messages to the WebSocket, and that's over here. It's very similar to how the submit name was done. So in the submit name example, there was a text box, and similarly, there's a text box to enter a new chat, and that's done here in this message input box. So when a message is submitted, this is basically just a form. So on submit, so when someone hits enter, whoops, it executes this submit message to chat function, and that is defined up here. And this prevent default thing is to prevent the page from reloading when you submit a form, because that is the default. When you submit a form, it like refreshes the page, but then that like restarts the state from scratch, and we don't want that to happen. So this is to prevent that, if you were wondering. So we're getting the current user and the current message that the user was typing. So when the user is typing a message, it's changing this current message body that is stored in our state up here. So when they're done and they hit enter, oh, whoops, my phone is ringing. When they're done and they hit enter, it goes here and we can access it from the state. So this new message type, this type is called new message, that is defined up there, again, in order to distinguish between the two. And in the message that we send to the socket, we also want to keep track of the username, the message body, and the timestamp that the message was sent at. So similarly to what we did with the new user has joined message, we're just going to send this message to the server, json.stringify new message. So that is how it gets sent to the server. But we also, from what you might remember before, on the server side, here, we're saying that if the current client that sent the message equals the client when we're iterating through that list, then we don't want to broadcast the message, as in we don't want to send the message to ourselves. And we wanted to do that with the new user joining the chat, because we didn't want to like tell ourselves that we joined the chat, or maybe you do, that's functionality that you have to decide. So here, since we already have access to the message that we sent, we still want that to appear when we render the chat, but there's no point sending that to the WebSocket really, since we already have access to that message. So I'm just gonna add this new message to my state so that when we render it, we can see the message that I wrote or the current user has written. So similar to what we did before, I'm just gonna copy this logic over here. And instead of incoming message, we want to add the new message to our list of messages. And then we want to update the state saying that all these new messages, we want to add the current messages that are on the list plus the additional message that we sent to the WebSocket. And then over here, we want to clear out the current message body back to an empty string, like that. So if we navigate back here, I believe we have to refresh every time here. And then I can see client connected, client connected. So I'm going to be Bob in this session, and I'm going to be Alice. And if I go to my network tab, over here I can see the messages, and when I type, you can see Alice's message over here. And if you check here, you can see that the new message was sent. And then you can talk to yourself like this, which is pretty cool. Awesome. We're running a little almost at time. So I actually want to go over how to deploy this, over how to do ping pong. So what I was mentioning before with ping pong is sometimes this connection will, if I don't like type anything and in any of the browsers for like 30 seconds, the connection might die. That's the browser just like closing any unused processes to like be more, like to not have anything that's unnecessary be running. So in order to prevent that from happening, if there's like inactivity, but you want to keep the chat alive, is to send a ping pong message. And I'll share the code with everyone after on how to implement that. It's just a quick ad here saying that when you start the connection, you want to send a heartbeat to the server. So it would be something like this over here, like heartbeat. So this is starting the heartbeats. And then in here, we send a ping message to the client. And then in the client side, we'll say every time we receive a ping in here, we want to respond with Pong. So that's kind of like sending these arbitrary messages, ping and Pong, back and forth between the client and server to make sure that the connection is still there and to keep the connection alive between the two entities, so that if there's like, say someone, like something happens to the network, like say you close your laptop or like one of the clients gets disconnected, you want to ensure that all the other clients are still connected to your server and the network disruption doesn't make that go away. So I'll send over the code for how to do that, how to keep your connection alive. But I want to quickly go over how to deploy this on Heroku, because as you can see, talking to yourself locally is not really that fun. So being able to share your creations with your family or friends in a web application is much more fun. So I used Heroku. I believe if I go here, it might take some time to load. You can see the chat app, and to deploy it on Heroku using Node doesn't take too long. So in order to do that, I went over here and made a new app. And if you're familiar with Git, it's pretty much similar to that. So if you have your changes running on version control locally, so over here, I have like some changes locally. All you have to do is follow these commands: git add, git commit, and git push Heroku master instead of just git push master. And you can create a new app here, and I've left instructions in the PowerPoint on how to do that. Before you do that though, you need to build your client app. So how to do that is if you go into the client app, and if I open this, if you do npm run build here, it'll run this build script, React scripts build, and it will basically take your whole React app and compile it down or create it into like a production build. And that generates this folder over here that I have in my server folder now. That has all the assets, has this index.html page. It's very long because it's all in one line. So it basically takes your React app and like compiles it into HTML, CSS. And once you have that build file, you just have to move it to your server folder like I have here. And this line over here says that when this page loads, so like when you go to this route here, like your index route, you want to serve the index page in the build file in this build directory. So that's what this is doing here. So basically your Express app is serving the compiled build that you have of the client. And then you can deploy it on Heroku in a few minutes. And I have some resources over here for how to do that. I'll share the code in the Discord after this presentation as well. But over here, here are some resources on everything that was discussed. So this is the client-side API documentation for Websockets. So that is like over here, the documentation for this API for the client side, how to initiate that. And then the Node WebSocket documentation, so that is for this library over here. There's also other libraries you can use. There's like Socket.io and like a bunch of other libraries out there that you can use on the node side. And this is a really great article from Treehouse, on the introduction to WebSockets. So everything I discussed in the beginning, like why the heck do we need WebSockets, that's in here. And then here's some React documentation if you're not too familiar with it and what I said like made no sense. This is a great way to learn more about how to manage the state of front-end components. And here is a Python WebSocket implementation and a Python library. You can do the same thing in, say you want to make like a Flask app or a Django app. Those are Python web frameworks that you can use. Instead of having like Express and Node, like you prefer Python, you can go and do that. And same thing, Java, I can find some Java implementations if you're doing that. But yeah, that is it. I will open it up to questions. I'm not sure how we want to do questions, like if you want to just say them or post them in a Discord channel. If you want to play around with the messaging app, like if you want to start messaging me now and here, feel free to go to ivyhacks.chat.herokuapp.com and feel free to message me there or like play around with it there. But yeah, thank you all so much for attending the workshop. And yeah, there's so many cool add-ons that you can do with the workshop. With WebSockets. You can do like your own Scribble app, like broadcast people's drawings, or you can also like broadcast videos and different things like that.
Awesome. Thank you so much. This was super informative, and I personally really enjoyed it. If anyone does have questions, they can put it in the event Q&A Discord channel, or you could unmute yourself and ask if you'd like.
Sorry, I'm trying to unshare my screen. Oh wait, stop sharing. Feel free to also ask me questions about like my day-to-day job or college or anything else. I graduated in May 2019 from Northeastern, so it's been not that long since I've been in college. It's been fast, but feel free to ask me any questions other, like if you don't want to ask about the presentation.
Isn't Northeastern the one with the really great co-op program? Did you do a co-op at Northeastern?
Yeah, Northeastern is like known for co-ops. Yeah, I did 2 co-ops during my 4 years there. Some people do 5 years and 3 co-ops. And I worked at IBM for my first co-op, and I did like conversational analysis, like physician-patient analysis. So all this chat stuff is something I love doing. And now I work at on a chat product or a chatbot product at Drift. And for my second co-op, I worked at a startup in Boston called Catalent, and it's basically like a consulting marketplace, both the software engineering. And I also had a little stint in BC. I worked at, if you know like Dorm Room Fund, I worked at Rough Draft Ventures, which is similar to Dorm Room Funds. We invested in student-run startups. And I also organized a hackathon. So love the hackathon community, love empowering student ventures or student makers. So if you want to ask me about any of that too, feel free.
Wonderful, yeah. And we received a question on the Discord. Someone asked, how similar is this WebSocket method to how live video conferencing works?
Yeah, that's a great question. So there's something called WebRTC, which is like peer-to-peer communication or like client-to-client communication. So with WebSockets, you have the server as kind of like the middleman So every time I want to send a message to everyone, it goes through the server and the server broadcasts it. But in WebRTC, it kind of like eliminates the server middleman, and you can just like broadcast between clients. So actually that method is better for video communication, video conferencing, where you don't really need that like server component in order to manage your communication. Yeah, does that answer your question? I'm gonna assume yes. But I actually recommend that if you're doing like audio, video versus this. If you're doing like a chat app, or if you have a lot of like server side logic that you want, if you want to trigger things from the server side, I recommend using WebSockets. Like say you want like real-time reporting. I'm thinking of like a Drift example where you're like crunching a bunch of numbers on the back end, like instantaneously, and you want to keep like pushing real-time updates on the server side. I recommend doing it using WebSockets.
Got it. And then we have someone who's raised their hand, Jennifer.
Hi, I just had like a question on if there's like a relationship between WebSockets and like AR, like augmented reality.
WebSockets and AR. I'm not too familiar with AR, like what the best development methods are for that. I know like Unity is really great when you're creating games, but when doing like real-time gaming, I recommend using WebSockets in order to like control, like manage like having the server manage the communication between the different clients. Like say you want to make like a memory game or like Scribble or something like that, or like Pictionary. I've never done AR before. I'm not an expert in that. So I'm not really sure like what technologies to use when building that. But yeah, I'm sure one of the mentors or someone in the Discord can help answer that. Someone who has experience with that.
Thank you.
All right, so we're almost running out of time. So you said you were going to be posting the materials on Discord after this. Do you have any last words, parting words?
Yeah, no, thank you so much for having me here, and thank you so much for listening to the presentation. Feel free to add me on LinkedIn or email me. I'll also post that in the Discord as well. If you have any questions outside of this, I know asking questions in video call is really scary. I would never do it. So yeah, feel free to ask me questions there, or like keep in touch in the future if you have any questions. Yeah, I hope you all have a great hackathon, and excited to see all the projects that you make. And maybe you'll use like WebSockets, real-time communication in your projects to like formulate the connectivity between people, especially now when there's like a lot of new like real-time applications coming up, or like even more so now, real-time applications are important as we're all virtual to keep people connected. So those are my parting words.
Definitely. Thank you so much for presenting and teaching us all of this. And thank you to everyone who joined to come watch. All right.
Bye, take care.
Bye.
Stay on for a little bit in case someone has questions or
And if you want, you could stop the recording as well.
Oh yeah. Stop or pause? Stop.
I think stop. Yeah.